Today we'll be doing range sum of binary search tree. It is an easy question on LeetCode. Now, what is binary search tree? First, I'll start with that. So, binary search tree, you can imagine it to be, you could say it's like a sorted version of a tree, right? So, sorted tree, let's just say that. The value in the middle. So, if we said 5, the value on the right of 5 will always be greater than that. So 10 is greater than 5 and 20 is greater than 10. So this is how the tree would look. And values less than 5 would always be on the left of 5, right? So the values that are less will be on the left, and the values that are more, they will be on the right. And the same would apply to things inside of the tree. 4 is not a good example. 3, 2, 4, and we can do 7 here. Now, one thing to keep in mind for binary search tree is that the main thing is considering your parent, right? When you draw the node on the right, so when we take 3, right? So let's take this node 3. If 3 wanted to attach a node here, for now I've put 4, right? But it still has to consider a 5 when it sees the value, because if we do something greater than 5, 6, right? And if we were doing a search through the tree, then we would simply say, so if we were doing a search through the tree and ignoring the 10, okay, if we said this, then it would basically throw off the algorithm, because you would basically say, okay, if there is, let's say, a 6 somewhere in here and our target was 6, okay, we would go to the right of 5, right? Because that's how we would search. We would say, okay, we check this value, it's 5 is less than 6, so value is greater than 5 should always be on the right? It can't be on the left and then be on the right of the left, because we violated the idea of having all elements greater to be on the right? So it's essentially just that. So you have to keep in mind the parent values that you have before like doing any insertions or anything like that. And it kind of plays, this question basically plays on the idea of that. If we have, let's say 7, I'll just take the question from LeetCode. So 7 through 15 in the tree, the values that fit inside are 7, 10 and 15. Now how did we get 7, 10 and 15? Right, you will see that the root is within the bounds, the value on the right of the root is within the bounds, and the value on the left and then the right is within the bounds. And that's how we would decide that. So this is the root, the right of the root, and the left and right. That's how we got it, right? Now the main thing to note here is that when you're given this range and you have to figure out numbers in between that range, there will always be, like, let's just say, call it an ancestor or like a node, at which point you will have to split yourself, right? You have to go both directions so that you can basically get all values within that range, right? And that's what the question is essentially. If we write the condition here, if low, so that's what we're given, right? And root.val, if we are in the middle, if we're directly in the middle of the range, so 7 through 15, when we check with 10, we're directly in the middle, right? 10 would satisfy this. So now if if our root fits that, then we can simply just first add our root dot value to that, right? Because we've considered it inside of the thing now. And we would send the recursive function onto both sides, because we don't know where exactly, we can't determine if whether the right or the left would have the thing, right now there's no information to tell us that. So you could say that 10 is the ancestor, where we will always split into both directions to see which one to go ahead with, right? But for definitions, for like roots that we can determine are, so if let's say root dot val is less than low, right? If we hit 5, let's say 5 and 7, right? That's how we have it in the tree. If we have root dot val is less than low, we know for sure that the left side will always be less than the current ones, than the current's value, right? And since we want to find numbers that are in the range, right, and we've got a low here, if we know that the value that we're sitting at right now is less than the range, do you think that 4 or 3 or 2, right, or 1 would be of any use if we looked at them and we had this range? No, right? It would never be of any use, because these are less than 5 and 5 is already less than the range. So we would always go to the right of the node that we are at. So we would say helper root dot right, you give it the low and we would give it the high. Now the same exact thing for the if root dot val is greater than high, right, that means we've exceeded our range now. So let's take a look at 18. Let's draw a hypothetical 16 over here, 15, right, and 10. If we were sitting at 18, right now, and we had the range 7 to 15, this was our high, and we saw that, okay, 18 is now sitting here. Whatever is on the right of 18 will always be greater than 18, right? But what is on the left of 18? The values that are less than 18, right? So we might be interested in values that are less than 18. So we would send our function to the left now. And that's pretty much all the cases that you have to consider. So 1, 2, 3 cases, and then the normal if not root return, and we would just define a helper here. You would say our root and then pass in the low, pass in the high that we get. Keep a variable res, because we had to store the sum, and then return the res here, right? So why do we do, I'll just reiterate through it all again. Why do we do root dot val in the middle of the range? Well, because we would not be able to determine, which way to go. There is no definitive answer to, if you go to the right, we'll find the value. If you go to the left, we'll find the value. You send it both ways, right? You add yourself and you send the function both ways. But if you have a definitive version where we are less than the range, we'll never find anything on our left after that. We'll always find it on our right, if there is anything. Same thing with being greater than the range. Going to the right after you're already greater, you will always only be greater, so you have to go to the left. And that's it. That should be the answer. Also, just don't forget to call the function, otherwise you won't see any changes.